Good morning. I'm Dr. Olaski from Mount Auburn Hospital in Cambridge. I have nothing to disclose. It's estimated that there are about 550 to 650 OR fires per year, and about 20 to 30 of these will be significant, causing disfiguring or disabling difficulties. Out of those, about 2 to 5 will actually cause death each year. Based on this, we believe that OR personnel must be properly trained in order to prevent and contain such fires. However, there are a lot of limitations on this training due to restrictions to using actual fire, of course, in the operating room, but also restrictions on smoke in mock ORs as well. Based on this, and since this is such an important topic, we really felt that training for OR fires may be best done in a fully immersive virtual reality environment. The VEST, or Virtual Electrosurgical Skill Trainer, is a tool that was developed in conjunction with surgeons, research analysts, as well as engineers, and it's for training OR personnel about the safe use of electrosurgery. Within this VEST trainer, we have several different modules. So one of the modules that I'll talk about today specifically is about OR fires. All of the modules were developed to allow trainees, practicing surgeons, anesthesiologists, and nurses to interact with a virtual OR environment. The fire module itself uses two primary components. There's a hardware interface, and there's also custom simulation software. The hardware interface is an immersive head-mounted display, so it's a 3D goggles, essentially, that you put on. It's a novel, fully virtual interface, and the user interacts with the virtual environment via a custom-built 3D printed controller. You can see an example of it here. So the user has their 3D head-mounted display on. You can see the interaction device is in their hand, the controller. And there's a tracking beam that they're looking straight at, but of course they're seeing the image inside the goggles. This simulation software involved in this module is self-contained. It relies on a variety of three-dimensional models that have been obtained from public domain, as well as modules that have been purchased and generated in-house. In this software, the user has to first identify the fire triangle elements. I've listed them here for anyone who's not as familiar with them. In this particular scenario, the oxygen is going to be the oxidizer, your electrosurgical instrument would be the ignition, and the surgical drapes would be the fuel. The user first has to identify these elements and then has to contain an OR fire. This picture here is a demonstration of what it looks like for the user, and you can see these different items here, number one being the fire extinguisher, and you can see the surgical drape, the fire itself. As you look around, you see laparoscopic screens. Number three there, which is the text that says anesthesia fire, that actually travels with the user and prompts them, since it is a self-contained module. Here we see that the user with the blue thing in front is actually their point and click. They've clicked on surgical drape, so it highlights in red, and they can click on a lot of things throughout the room. It again prompts them if what they've clicked on is correct or incorrect, depending on what they're supposed to be identifying at the time. Here they've clicked on the IV pole, so that's incorrect. So just to show you a little example of the module, in this part, this would be after the user has already identified all of the important items that are in the room that they need, and they've already identified the fire triangle. So when you're actually watching it this way, it looks a little blurry because you actually need the head-mounted display in order to see the 3D vision. So when they're looking at it, it's a lot more realistic looking because it's not blurry. And we actually have this downstairs at the Learning Center. So if anyone wants to try it out, you can see it's pretty startling when the noise starts. And it really does give you a feel of an actual emergency and really draws you into the scenario. So therefore, it's replicating an actual emergency. At the very end, it tells you the fire has been extinguished if you've taken the proper steps in the proper order. And also it reviews what you've just done. So there's a little additional education right at the end of the video. We decided to do a face validity study at SAGES 2015 last year. And we had subjects who were asked to complete the OR fire training and prevention sequence in the VEST trainer. Afterwards, they filled out a subjective preference questionnaire, and we tried to focus on questions that talk about the usefulness and validity of the simulator. You can see our results here. 92% of the questions received a 3 or higher in the score. And you can see the top ones listed there: the better understanding of electrosurgical principles, more effective compared to textbooks, more enjoyable than textbooks, and VEST simulator recommendation to peers. Those were all the highest scored on a Likert scale of 1 to 5. And the ones that scored the lowest were still a 3, really nothing was below a 3, was tissue effects, instrument handling, and the realism. The face validity of this training module was successfully established in many aspects of the simulation. Based on the feedback that we got from the users, we will be making further refinements in order to improve the areas that were not rated highly. In the future, we also hope to be able to incorporate an objective evaluation of a subject's performance. In addition, down the road, we would like multiple users to be fully immersed in the same environment, so you could have an actual OR nurse, anesthesiologist, and surgeon all in there at the same time, which you can imagine might be somewhat chaotic, but would be even more realistic. I'd like to acknowledge the NIH grants that were involved in this project. In addition, the FUSE VEST Advisory Committee, particularly Dr. Monroe, who has given us valuable feedback in order to guide this research. Thank you.